Amazing. Kent, Matt, how we doing?
Doing well.
Morning, everybody.
How are you, Armon?
Doing fantastic. That countdown was pretty nifty. I enjoyed that music in the background. I wasn't expecting that. For everybody that's already on, we're going to give it a few seconds, maybe about 30 seconds before we really kick into things. Just let people trickle in as they want to hop on and be involved in the conversation. So as you're coming in, if you want to post a comment, let us know you're here, get a shout out. I'm sure we'll see some of our old and new friends here. Good morning, Aswin. And yeah, good evening to others that are
You can't hear us, Dale? Dale says he can't hear us.
Dale, you got to turn up your volume, man.
Unmute.
Hey, Trevor, there you go. Some representation from New Zealand. Amazing.
Fantastic. So Ken, let's see your mug for coffee with Coalesce, Kent.
There you go. I actually have elderflower tea.
Oh, there's Dan Scott, the man. Hey, Dan.
Mr. Norm Gonzalez has joined. Hello, Norm.
Hey there.
It's been a while.
Can everybody hear us? Because Dale was mentioning that he was unable to hear us. If you can, just throw a comment that just says yes. Hey, Stuart.
Dale. Volume all the way up, so Dale still can't hear us, huh?
Mike Migalski, hello. Vincent, good evening. Love the coffee. Good. Hopefully you got some, Lucas. Okay, great. Marcy can hear us. Appreciate it. There must be a little bit of a delay.
Kelly, all the way from Finland.
Wow, we got a full house.
Okay, everything's coming in now. All right, apparently people can hear us now. I think we're good. Can hear you loud and clear. Thanks, Glenn.
Hey, Satish. Hi, Jeff. Jeez.
Perfect.
Okay, I think we can do this all day. Why don't we get started? It looks like there's a lot of eager people here, a lot of people that hopped on to hear about something that has been around for a long time. The concept of data modeling has been around for a very long time. I know that both Kent and Matt have deep expertise when it comes to data modeling. Why don't you both just give a quick intro on yourselves, and then we can hop into some questions.
Sure, I'll defer to Kent.
Thanks, Matt. Yeah, so hey everybody, it's Kent Graziano coming to you live from Galveston, Texas. I've been in the data space for multiple decades now. I won't tell you how many, you'll have to guess. It's been a long time, and my area of expertise was traditionally in data architecture, data modeling, things like that. Started off with Oracle Case back in the early days, an Oracle designer, and then as many of you all know, I eventually moved over and joined Snowflake when it was a startup, and was the global evangelist there. And at least 50% of my time at Snowflake was talking to people about data modeling and how to model data in Snowflake, and how to best represent their use cases with data models.
Awesome. Matt?
Yeah. So, the funny is that Kent and I came up the ranks in the same path, even at the same companies. Both of us were over at Oracle, been there for a long time, where Kent was out delivering topics and doing Case and Oracle Designer, and I was in the classroom teaching Case and Oracle Designer and doing data modeling, and had full classes of data modeling going on site and out teaching it. And then over the years, I didn't do the cool things like Ken. I didn't join up with Snowflake, but I've been out in the field consulting, delivering, doing lots of data modeling from different companies, and helping companies along the way with large enterprise scale applications, and going back into the heart of just data and analytics and building good data. So been there for a while, like Kent, we'll just say decades, and then let other people do math.
Awesome. I gotta say, I'm delighted to have you both here. I think that it goes without being said, but you two are some of the most knowledgeable analytics professionals I've ever met. For those of you who don't know me, I'm Armon Petrossian. I'm the CEO and co-founder of a company called Coalesce, which is a data transformation company focused on automating as many of the tasks associated with data transformations at scale. So why don't we jump into it? I feel like there's a lot of interest right now around the concept and topic of data modeling. And it's really interesting to me because for a while, people were a little bit quiet about data modeling, or at least it wasn't as popular of a subject. And we're seeing this roaring comeback when it comes to data modeling today. And obviously the title of this event is The Future of Data Modeling, but it would be helpful, I think, for a lot of people just to start with what is a data model? What is data modeling from each of your perspectives? At a high level, can you give our audience a background on what data modeling is in the first place? So why don't you go first, Kent?
Wow. Yeah. So definitions have changed over the years, and there's been all sorts of debates on the, what do we mean when we say a data model? Today, in particular, it's gotten even more confusing since we now have machine learning and people talk about machine learning models. But from the traditional perspective, a data model was a way of representing the organization of the data. And it could have been at a conceptual level where we're really talking about, ideally, how is the data represented in an organization? What data does the organization care about? What are the relationships between the various aspects of the data? And back when I started, we called that an entity relationship diagram or an entity relationship model. And then that was kind of at the conceptual level. And then you would have like logical and physical representations of that. And over the years, depending on the platform, whether you're using Oracle or Sybase or SQL Server or Teradata, Snowflake, people will often have to have slightly different physical representations for performance reasons. That was one of the things nicely Snowflake solved that problem. You didn't have to design things specifically for performance in Snowflake, which I found to be a great relief. And when you get down to that level, you start talking about really a schema model. What's the design of the schema in the database itself? So you have a lot of different definitions on what data modeling is. And as you said, it's like, Armon, you mentioned it kind of got quiet. Well, from my perspective, it didn't really get quiet. People just got stupid. I mean, back when NoSQL came out, people started saying, oh, we don't need a data model. We're going to do schema on read, right? And that was the beginning of the end in my mind, when people said, oh no, we don't need to model the data. We're just going to throw it into a document store. Or we're going to throw it into XML, or we're going to throw it into JSON, or we're going to throw it into flat files. And we're just going to get the data out there as fast as we can because we're being agile. We're trying to be agile now, which we're great for application developers in some instances to build applications fast. But then those of us on the analytics side, we're left holding the bag going, how do we get that data out? How do we make it make sense now? Because you just kind of thrown things in and it doesn't have, the organization that we necessarily need to do good, effective analytics. And so, that was the whole NoSQL world is, oh, we don't need no stinking data models. Like, oh, come on. There's still a data model there. You're just ignoring it.
Now right, yeah. It's interesting you say that. And Matt, I'm very curious to hear if there's anything you'd like to add behind how you would describe data modeling. But the follow-up question that I was going to ask is, what really led to it being less hot of a topic, and why is it making a roaring comeback in your opinion? So maybe Matt, if you want to add anything to the description of a data model, and then also from your perspective, like on top of the NoSQL movement, we saw data modeling be disregarded even in the early adoption of Snowflake. It was less of a priority for some reason. And maybe that was the NoSQL movement potentially. I've got my opinions on it, but yeah, Matt, why don't you chime in here and share if there's anything else you'd like to add on the definition plus what really led to that?
Right. I mean, Kent laid out some solid foundations of what it is, right? It's And the data model, really, as Kent pointed out, is that representation of the business. It describes, if you have a data model, all you're really doing is describing the business, what is important to the business. And being able to articulate that is so important so that everybody has a shared vision. And I think that was one of the most important pieces when we were building data models and teaching it and talking about it with customers, is that the data model isn't just an academic exercise. The data model was creating this shared vision of everybody saying, this is what represents the people, processes, and business that's important to us. And back in the 90s, I think that we saw a lot of businesses really value that idea, that this represents us, this represents what's important to us. Let's go and make this a reality. So when you ask why don't we talk about it as much? I think that over the course of the past 30 years or so, I think there are three things I think that really brought that down. And Ken alluded to one of them earlier. It's the rise of agile. The rise of agile, you had people saying that code is more important than documentation. And they viewed a data model as simply documentation. And they didn't see it as that shared vision, which was important. And they did this to a lot of other modeling too, but that really brought that down. The second thing I think that brought it down, that deteriorated that shared vision and the value of that model, was when you had that physical model, that representation inside of an ER diagram, then become disconnected from what was in the database and physically implemented, because changes just happened in the database, and then the two became disconnected because they weren't done as a logical system. So they broke apart, and then it was too much work to continue to maintain that model of what they saw the business as. So they stopped doing it. And then I think the third, and again, Ken already alluded to this, was this, with the rise of IDE tools, that a developer could so easily create the data objects at the database inside of the IDE, they started creating models that represented their program and their screens and did not follow good data practices. For expediency, they created things that looked like what their screen looked like, but didn't necessarily look like what the business was reflecting. So because of all those, and they just compounding effect, that the business started valuing it less, and then as a result, we stopped teaching it. So it's not hardly taught in universities anymore. You don't see it in boot camps anymore. So people aren't learning it. So what's left, and why we don't talk about it so much, is because it's left to people that actually know how to do it to then retrain and teach other people what good data modeling actually is and why it's important again.
Yeah.
The only place that I see it's actually being taught anymore is actually in the data vault world, because now there's at least 3 organizations that are running data vault boot camps all the time now, every month, sometimes multiple times a month. And that was part of this resurgence that Armon is referring to. This started a couple of years ago when I was at Snowflake, as people started getting interested in data vault modeling for analytics. And so those are the only modeling classes I see. Like you said,
right.
Matt, you used to teach Oracle Designer and Oracle Case classes. Well, part of that was teaching people data modeling. And because folks got less interested in it, then of course organizations like Oracle and big training organizations stopped teaching it because there wasn't any demand.
Right.
And it became a vicious cycle, right? We talk about a virtuous cycle. This is like a non-virtuous cycle, right? Is people stopped getting interested, so we stopped teaching it. So then people who wanted to learn it couldn't even learn it, and now we're down to where we ended up with data swamps, right?
Yeah.
We ended up with your description, developers pushing data structures that basically mimic their screens. And one of the benefits, I learned very, very early on in learning, third normal form modeling, one of the goals was to eliminate what we called update anomalies, right? And when you design the structures behind an application, like the screens, you end up with update anomalies. Because if you have, addresses was the perfect thing. It's like every time you entered a person, you had to enter their address. Well, if they bought 5 things and it was all on one screen, you had 5 records for that customer and potentially 5 different addresses, because it's all embedded in the one screen. And so there was no cross-referencing. And that makes, the analytics, trying to say, how many customers do I have? Well, I've got 5. No, actually, you've only got 1. How many addresses do they have? 5. No, they really only have 1. You've just got 4 misspellings. That made it a lot harder on the analytics side, because that got into our data scrubbing and our data transformation rules. It's like, how do we clean this data up so that on the analytics side, we can do data-driven decision-making on good quality data. And that's kind of, I think, one of the outcomes of people not, say, paying attention to good data modeling practices at any level, is then you end up with bad data quality. And like I said, that eventually led into the whole data swamp thing. It's like we had data scientists spending 80% of their time cleaning the data up, because it is such a mess, before they could actually do anything useful with it.
Yeah, it's really interesting. I find it peculiar that now, of all times, it's making such a comeback. We all have our stance on what led to it being less hot of a topic, or less taught, in different programs. But it's becoming so much more popular by the day. I see Chris Tabb posting in the comments, talking about hashtag bring back data modeling. I see comments here. Somebody saying that the modern data stack with ingestion tools focus on dumping data, and giving you the access to do quick analytics for the focus of short-term success, then leading to spaghetti SQL, rising consumption costs, and that modeling was the base for avoiding those things. And so would you say, Kent and Matt, that the reason why there was a period of time that data modeling wasn't as relevant was just because of the access that people had to data that wasn't there before, prior to the cloud, prior to the automation of being able to ingest data one for one from source to target? Is that what led to it? Is that why there was?
Well, I think, I don't know that I would say, data modeling's always been relevant, right?
Yes.
Just ignored. And it goes back to even Matt's comment about agile, is with the new access methods. And I certainly saw this when I started with Snowflake, because it was so easy to onboard the data and the engine was so performant. There was a thought for quite a while that, well, we don't really need to worry about the model of the data because it doesn't have performance impacts. Well, yes, true enough. Didn't have performance impact, but not having a good organization of data did ultimately make it hard for people to still pull the data and query the data and get the right answers, and also be able to, as Matt kind of alluded to earlier, explain the data to people, right? If the data is not got a great level of organization, you can do the first use case, right? And this was back in the day when we first started doing data warehousing. Siloed data marts were the same thing. It was the same result. It's like, well, we'll just build this quick little star schema that answers these 5 questions. Great. Well, what about question number 6? Oh, yeah. Now we got to re-engineer the whole thing because we can't answer question number 6. And I think in that, in our hurrying to get to answers, we took shortcuts. It was like, oh, well, we don't. Data modeling is going to slow us down, and that was something that came out, in the agile time as well. Like, oh, we don't need data models because it's just documentation. And if we get a data modeler involved, it's going to take them years to do the model, and that's going to slow the whole project down. And that was just, a bad approach, and people not understanding how to be agile with the modeling, which a bunch of us eventually learned how to do. And really, I think it's just that people were not measuring the opportunity cost right, really. They're thinking, well, we can get this done really fast, but we're going to skip all these steps. Okay, and it worked great for, again, like I said, like a POC, pilot project.
Right.
If you've only got one source of data, actually, you're fine, really, especially even like with Snowflake. If I've just got one data source and I can use something like Fivetran to onboard it, and then Coalesce to move it along the pipeline. I don't need to worry about changing the model that much because it's just one source. So the data is consistent within itself. And you just got to figure out how to query that data, right? How to join it together properly, depending on what the source model looked like. And you can get away with that. But as soon as you start getting 2 or 3 or 4 sources of data, and each of them has bits of customer information, bits of product information, well, now it becomes a lot harder to put that together, especially because we're trying to democratize the data now, right? So how does a business end user traverse data from 5 different source systems and figure out how many customers they have? And that's putting a lot on them, right?
Yeah, and I think that point there is so important because when we were doing data modeling, and a lot of our discussions, as you pointed out, was about performance. In the cloud world, the performance switches over to you do data modeling because you're concerned about compute. If you have bad models or you're not even doing any modeling, that is one of the things that will actually end up driving up your compute costs because you're repeating pipelines.
Yep.
You're creating new pipelines off of the same source data again and again and again. And Mike Majeski, he and I have these conversations in the past and use the same analogy. The modeling is about sorting your Lego bricks. And it's a great analogy, Mike, because it is about sorting them out. It's building these domains. And I think that's one of the reasons why we see the rise of more discussion about Data Vault, because Data Vault is domain data modeling. It's putting things together in logical domains and building data products along the way that then are consumable and reusable. And the pipeline, what we do, makes use of those. And we do it because we're doing it by intent, right? We have a model, and your Data Vault can be model. It could be a data engineering pattern that drops off reusable products along the way, which is really just good software practice, is to make use of reusable objects. And so data engineers that do AI and data science work and stuff, they're spending so much time discovering data that somebody else had already scrubbed, cleaned, standardized, and not reusing data. And a data model really is about publishing out reusable, consumable artifacts that you can go and make use again. And that'll end up lowering your compute costs because you're not repeating pipelines. If you can cut out 80% of your pipeline and consume a standardized data set for AI and ML, man, go and do it. And that's so important to be able to do. And it's just got to change the mindset in the world of cloud. And that's
right.
A lot of people haven't made that shift.
And unfortunately, it actually harkens back to the early days of data warehousing, where you had departmental data marts, where each department was often loading the same data into a separate server to do their localized reporting. And then when you tried to put it together at the enterprise level, you had all this redundancy. Right. And again, this is the downside of the cloud and agile and the modern data stack. Is it's a lot easier to onboard this data. And so without any sense of organization or structure or discipline, exactly what Matt said, people are loading the same data. And if we look at the data mesh paradigm now that talks about data products, if you did that right, then this wouldn't happen, right? Is the data domain specialist would load their data, and all of that data would be put into a model and into a product that's easily shareable with the others. So we're not using extra compute to load that same data again and potentially get different answers across the different domains because you loaded it just a little different. This was a problem back in the early days with ETL, of ETL developers loading the data and applying a slightly different algorithm because they talked to a different business person on how they wanted the math done on, say, gross profit, or how are you going to, what actually counts as a customer. That was always the fun one. It's like, well, what do you mean by customer? right? And you get different definitions of customer. So you get different customer accounts when the CEO asks. One says we got 5,200. The other one says we have 752. It's like, well, how did we get such different customer accounts? Because the definition was different. And that's back to, some of Matt's earlier statements, the use of a data model as a communication tool. Today, people talk a lot about a semantic layer, right? And to me, it's a semantic model. And that's what the original conceptual data modeling was the semantic definition of the data in business terms. That's what it was supposed to be. Right. And then we started shortcutting. Oh, we're just gonna design tables, right? And we're just gonna create table with all these columns and these data types, but nobody ever put the definitions in. So nobody actually knew what was the meaning of that data and the meaning of that column and the meaning of behind the table, because they skipped that business modeling aspect of it. And now everybody wants a common semantic layer to query against, right? They don't want to have each tool having to load the data into a basically their own little modeling layer, whether it's Tableau or Power BI or whatever it is. We want to point to one semantic layer so everybody's using the same definitions. Well, now we've just flipped it around, where in the old days when Matt and I started, it's like we did that business model first, and then we physicalized it and put it into a repository so people could report on it. Well, now we've been shoving it all into the repositories, but oh crap, we need a common model on this side that we're now calling a semantic layer in order to do consistent reporting and enable the democratization and easy access for data scientists, for data analysts, for business analysts, for all of them, and have everybody looking at the same thing, and they know it means the same thing when they ask for a definition.
So yes, this is one of the things that excite me most about data modeling becoming more and more popular, or at least not ignored anymore amongst all the comments I'm seeing here, which are all amazing thoughts. It's clear to everybody that data modeling should be a core focus, really is around incorporating or encouraging good data architecture. And we see this all the time at Coalesce as we go to different companies that started building things in that same mindset that you described earlier, Kent, where it was a small use case, or it was a POC, or it was a pilot. There was no proper data modeling done prior to actually building out the physical design of their data warehouse or data project. And now they're starting to feel that pain years later and realizing, oh crap, we should have been a little bit more thoughtful about how we went about doing this. And that's why there's some comments here talking about how it brings down the TCO. If you have a proper data modeling approach, you're not having parallel pipelines that are doing the same thing. You're not having as much confusion around certain questions the business asks and definitions that you're trying to describe, because you've planned out some of these things ahead of time with the business and really been a little bit more thoughtful about how you went about building. So with that said, with that in mind, there's a lot of questions that are coming in. A couple of them are related to what I was going to bring up, which is all around the future of data modeling. So we talked about the past. We talked about where we're at, what the status quo is, how there's a comeback when it comes to data modeling and the focus of it. I see some questions asking, are Kimball and Inman's approach to data modeling still relevant? I know, Matt, Kent, you both are big on data modeling, and there's also the data mesh concept that you brought up earlier, Kent. So from a high level, if we're to think what the future looks like when it comes to data modeling, how do you see companies of various sizes approaching data modeling, whether they're small, medium, enterprise, major business? How would you advise them? What do you see is going to happen when it comes to data modeling to ensure the success of an analytics organization?
So, I think coming back, the first thing that comes to mind in here is that the role of the logical model still is critically important. As you said right at the beginning, It is what creates that common vision across to everybody as to what is that we're going to do and what is important to us. So that logical model still hits home. And it actually can be in anything. That logical model can be crafted inside of a traditional ER tool. It can be inside of some free drawing tool we've done through collaboration on a collaboration whiteboard. It could be done on a bar napkin. It doesn't matter. The medium to create it doesn't matter so much as long as you're actually creating that shared vision. And then that vision, it shows you what you want to get to, because in it, I can start to see that I'm a global company. I have my centralized data, but I also have organizations organizations over in Europe that needs to have just GDPR data that's going to stay in Europe, and I'm only going to sit over there in Europe. I have data that's just sitting down in Australia. I have data in the US. And so that itself starts to shake out to say, you know what, I might need to pick up some of these pieces of the data mesh concept, the data mesh principles, to have centralized and meshy looking data on the side so that it all works together. And in all that, funny enough, goes and leads to the idea that modeling data in domains makes sense, because then different mesh type of objects can connect into that mesh and then expand on that domain. The actual physical, today I'm less concerned that the physical model is rebuilt inside of an ER diagram as I am in some of the just pure modeling tools like Coalesce, right? Coalesce, I can go and see my visual model. I have my picture of what I want to do, and I can engineer my way into that physical model and engineer products, data products with intent to build that model and get to an end state. And Coalesce, in my view, gives me more value of what the physical model in the end represents, because I not only see what did I produce, but I have the entity definition of what it's there. It tells me the schema model of what I created, and it gives me the column lineage of how I got there and what it actually means. And having all those pieces is really some of the things that was missing before when Kent and I were first doing data modeling, that it was harder to find that lineage back. Now inside of a modeling tool like Coalesce that lets me engineer and model, I actually can see all of that. That is so powerful for both me as a producer of data products and for consumers of data products.
Yeah, I think that it's for the future. The first thing I would say is the future of data modeling is you need to do it, right?
Yep.
There's a lot of debate, a lot of comments going back and forth. Well, is it Data Vault? Is it Inman? Is it Kimball? Yeah, one person did rightly point out Bill Inman signed on board with saying Data Vault's the way to go for analytics back in 2008. So we should stop talking about the Inman modeling technique. He's like, yeah, don't do that anymore. You could still do it. I mean, it's third normal form with a timestamp, and that is less important than the fact that you have one and that you standardize on it. Now, I think in the data mesh world, I've believed since first reading about data mesh that, and I think Matt agrees with me on this one, is that the Data Vault approach is probably the most appropriate for that because of the ability because it's such a granular level of modeling. It's a lot easier to build independent data products and hook them up together if you're dealing with hubs and links than if you're dealing with, say, facts and dimensions. Now, on the consumption layer, Kimball is still relevant. Many use cases, star schemas are going to be the way to represent the data to the consumers. Now, does that mean you have to have facts and dimension tables in your database? No. It could be just views. Again, we're back to that conversation about a semantic layer. It's like, how do you represent it? And I think what I've seen in the last couple of years, and I still believe is going to be relevant going forward, is that because of the power of the compute to do joins and do complex things that we couldn't do 10, 20, 30 years ago without physicalizing it, that we should be less concerned about which modeling technique we use for the consumer side. You use the modeling technique that's most appropriate to make it the easiest for for the consumers to get the value from the data. So for a data scientist, they don't necessarily want a star schema. Right. They want a 2,000 column feature store, right? What's that? Well, that's denormalized. That's just flatten it all out like you did in a spreadsheet, but represent that in a view. For certain tools, facts and dimensions are still going to make the most sense. For other tools, there's a couple out there that still want snowflake style schemas. It depends on the end user, the tools that they're using, as to which modeling technique is going to be the best. If you're using a graph tool, right? Say using what is it? SQLJ. There's a couple other things out there. Various graph modeling tools, graph databases, graphical representation, knowledge graphs. It's going to look a little different. It's not going to be a third normal form model. It's going to be a knowledge graph, and that's appropriate. But how you store it underneath, if you're using a modern platform,
right?
More and more, it's starting to look to me like it's Data Vault 2.0, right? And I know Matt's been doing a lot of that now because it's just the challenge with data modeling that got such a bad rap was what I'd said earlier is, the data modeler is going to take a year, right? To do an enterprise data model. Yeah. I saw programs that took multiple years and they didn't accomplish anything other than diagramming the semantics of the business.
Right.
They didn't know how to break it up into small chunks and say, well, let's prioritize. We don't need to have the whole business modeled in order to achieve these goals. So let's prioritize the goals. This is something that came out of Scrum. Prioritize backlog. The Agile world gave us a lot of great tools to think about. We just have to figure out how to apply them. So let's just model that piece, right? Model that one source system or those two source systems. And again, getting into the data mesh world where you've got different domain teams, they can now work independently and model their data. And if they take a data vault approach, then you've got hubs and links and satellites. And then eventually it's a lot easier to tie those all together because the relationship between those independent domains, there's relationships there. And how do you model the relationships in this kind of world would be in a link from the data vault perspective. How do you represent it to the outside though, may be very different. And that may in turn be represented as a star schema to the users that are actually going to consume it. And so we have to think about all of that. And data mesh, when it talks about data products in the data mesh world, they talk about, you need to think about the consumer of the data as well, right? And how you're going to put together, what is that data product going to look like to the end user? And there's, you have different constituencies. You may very well have different representations of the same data because of the way they're going to use it. And I think the power of something like Snowflake gives you that ability to do. So you're not duplicating the data. You aren't replicating the pipelines over and over again to get a different representation. Yeah. So it becomes more virtual. I guess that's what I'm getting to is the data modeling is becoming more virtual and pushes us back to that business semantic type modeling on the consumption side rather than up front, though it's useful to do both and they should be connected. And like you said, having tools like Coalesce where we can do the lineage, we can see how we got from here to here. Right. And what happened in between.
And the other important thing out of all of that, Kent, is just the removing the religion from the model, right? And I think that when Zamek put out that data mesh, her biggest fear was that it would become another religion. Inman was religion, Kimball's religion, Data Vault's religion. Remove the religion from it. Yep. You don't need to go and I need to do that because I think that those groups that coalesce, that move around a religion like that and are so strident that this is the one and only thing that is my world, brings this whole thing down. And you see that in the modern data stack. There's people that just are so fervent about this is what I am. Okay, a tool doesn't define you. Number one. Modeling methodology does not define who you are as a person. So use what's right. Be pragmatic in it.
Yeah,
absolutely.
I've seen you, Matt, be one of the best data practitioners, which is why I was so excited for you to hop on, because you have always taken a very pragmatic approach to data warehousing, data projects, and I really love the stance here around how do we make the business successful, and really it's a hybrid approach. It's not one thing or the other. And I think that's why data mesh has become so popular conceptually. There's a lot of people talking about it because really what it's aiming at accomplishing, at least my understanding of it, and I would love to hear both of your opinions on it, is that you've got a centralized repository, you've got your raw vault or your initial data model that's built by the IT team or the data engineering team that's supposed to then be extended off of to the departmental users or to the citizen data engineer in a specific department of the business, like finance, sales, marketing, where now you have a holistic view and everybody's on the same page when it comes to the design of that data, where you're pulling that data from, versus that siloed effort. It's a lot more expansive. It's a lot more accommodating architecture for the entire organization versus what's traditionally been done as centralized IT teams build their own version of the data warehouse. Then you got the finance team builds their own data mart. Then you've got the marketing team that builds their own data mart. And for the first time, I would say the infrastructure with something like Snowflake can support what the entire company needs, the entire enterprise needs to actually democratize data. It's now possible. The infrastructure is built to do that. It's just a matter of how do we encourage the right adoption, encourage the right architectural approach so that the IT team and the business are on the same page at all times and working off of the same foundational layer or foundational data model.
Yeah. And it's all about you got to have a good data culture around this, and building the data culture along with data literacy inside of the organization, regardless of whether you're going to build data products, just build data products in a big enterprise data warehouse or inside an enterprise data lake, or if you're going to do a data mesh, you've got to have an agreed upon approach. But that also means you got to have standards, right? So, the data mesh framework says, the rules is the domain teams who know the data, they build those data products, and it doesn't stipulate should it be in a common repository or not. It just stipulates they need to be interoperable, right? And you're right on the money, I think, Armando, with Snowflake, with the data sharing capabilities and the power of Snowflake and the ability to connect multiple Snowflake instances,
right,
with the data sharing features and the data marketplace features, that allows you to have a common platform. And all the folks that I know that are doing this successfully, they start with one project and they set standards and they pick a data modeling approach, and many of them are picking Data Vault, but they set it up and they have a center of excellence, and that becomes the IT role more now, is to set that center of excellence, set the standards, help people learn how to use the right tools at the right time for the right problem, and then let the domain teams build these things independently. But you have to start there, what in the agile world we would have called sprint zero, and set all of that up so that you don't end up with data silos, because there is still a risk of data silos as people think they're going down a data mesh route and empowering these independent domain teams, and then each team is using a different tool, each team is using a different database, each team's using a different modeling technique, and then you'll end up with more data silos and independent data marts that can't be connected together in some sort of uniform way. And so it has to start at the outside, right? The big picture is, what are we trying to accomplish as an organization, and then get down to the decentralization. But it's got to be, Dan Lindstad in the Data Vault world, people were always talking about, they wanted self-service analytics. He said governed self-service analytics, right? Right? It just can't be a free for all, right? Because otherwise we will end up. The beauty is the beauty and the curse of the cloud is you've got all this power, but that means we can end up with more silos faster than we ever imagined, right? Di Clegg at Oracle. I don't know if you remember Di Clegg, Matt, in the Oracle case world.
Yep.
At one conference one time, we were talking about rapid application development, and he said, "This gives you the opportunity to build legacy systems faster."
Correct.
Right? It's like if you don't have the discipline and you don't have a plan, and that's where again the data modeling comes in. Is having an approach that is not a free-for-all, you'll end up with data silos, you'll end up with independent data marts, you'll end up with mismatched data, and you'll end up with a data swamp, which is where we ended up with, where it's not really that valuable to anybody, because at some point it gets to the point that nobody can really use it effectively because there was no discipline from the get-go. Yeah, we got started fast, but then we went nuts, and now we've completely lost control. And I think that's why you're seeing the data modeling come back, is because a bunch of people did that over the last decade and went, okay, yeah. And like you said, we don't want to burn too much compute on Snowflake because that can get pretty darn expensive. So let's not be stupid about this. Let's be smart. Let's put some structure in place, put some standards in place, and then we can get to delivering value faster. But you can't just start right out of the gate with that, because otherwise you end up with a mess.
I saw a LinkedIn post a few weeks back. Robert Godfrey pointed out that the data vault modeling in there, that central delivery, is equivalent to a train, right? A train can move large amounts of product across the country and go many, many miles on a single gallon of gas. And it's moving these large volumes. And that's what central IT, and that's the central part of the model, does. It moves the large part of the data to up until that last mile. And then the last mile, which is where the data scientists and the AI modelers and the data consumers for report analysts go and connect up and take the data the rest of the way to what will meet their needs. But you have to still design something so that you're moving data the most efficient way, modeling it in the best approach quickly to move it, and then let it be consumed. We don't need to, when we started modeling, we don't have to do the same things we did before. Because when Kent and I started with data modeling, it was because we were designing for limitations of hardware, compute, and software.
Yep.
We were solving problems limited to that. And even if you read Dan Lindsted's stuff on Data Vault, he originally created it to address limitations of hardware and software. Now, those limitations aren't as there, but you still need to be smart about what you do. And you don't need to move the same data 20 times. Move it once. Treat it like a train. Move large volumes, and then tap into it and start pulling that data off in the way, in the shape, and the form that you need, and reshape it. But if we standardize data once, that can be consumed by the many AI and machine learning engineers, great. And that same data that we standardized flowed into a Kimball Mart for reporting tools, great. Sigma will go and tap into that and create a nice report and ad hoc and scan that data. Fantastic. Well, we're doing it all off of the same standardized. We move that data once into that standardized block and then started consuming it. And that is so important. It makes such better use of your compute and being very intelligent about the intent of your objects and the intent of your products. So design them with intent. And I think that's honestly, Armon, when I saw Coalesce and I saw what I could do with it, that was one of the things that struck me first. I can visually design with intent what my logical model is. And that gave me so much more power over any other tool out there, where I saw developers just 100 different pipelines all to do the same thing and not having any intent about what they left behind in their process.
Do you think that it compresses the time that it takes to data model? Is that something that's evolved? Kent was talking about being at companies where they spent a year building out the enterprise data model. They didn't build anything physically. And so when you talk about using Coalesce, Matt, and the experience around going through the data model design, has that been something that can compress that timeline? So you don't have to spend a year building out the data model.
You do not
spend a few weeks or maybe, a month tops. Like, what does that sprint look like to both of you guys? How do you feel a company that's embarking on a data journey, how much time should they spend building out that first initial design, that first initial data model? I know it depends on the size of the business, but of course, what's like a appropriate time frame to be thinking about this prior to actually getting into the physical build?
I think you spend time thinking about what your logical design is, what it is that you're wanting to achieve. I think you spend time there and you get alignment with business as to what it is that we're all wanting to do, what is important to the business, right? And then that question of importance includes, how do you intend to grow, right? If you're measuring for the performance and growth, then how do you intend to grow? Well, we intend to grow through mergers and acquisitions.
That's a great point.
Okay. All that makes importance. And then that way I can now go and design and model that intent quickly inside of Coalesce and quickly test out. And most importantly, one of the value points of Agile, it lets me fail quickly.
Yep.
I can actually tangibly work with data and fail quickly with it, and then come back out with a better design. Back in the day, we failed slow and we stuck with bad ideas.
Right.
And it just dragged it down. Now let's go and design it with intent, quickly, test it, and then confirm we're going to go with this or not.
I think the funniest organizations that we talk to that have the most problems are the high growth startup who didn't think about how quickly their company was going to grow. And so they neglected data model. Whereas a company that's going through mergers and acquisitions, for some reason, has seemed a little bit more thoughtful about how they go about data modeling. I still think there's areas for improvement on both ends, but the high growth startups that adopted cloud platforms, started building out data pipelines, and then things just grew so quickly are the ones that I've seen the biggest horror stories personally. Now, mergers and acquisitions, like you brought up, Matt, is a totally different design, totally different way to design your data model. But in both cases, you've definitely seen some horror stories. I think when it comes to preparing for the future, that's what I'm hearing from you, is that it's basically what's the intent of the business? What are we aiming for? Are we trying to become a multi-billion-dollar enterprise, even though we're just 50 people today? Are we going to go through acquisitions? Are we going to have tons of different data sets coming in all the time that are kind of similar? And then figuring that answer out before actually building out the design of the data model and then going from there. So that makes sense. I think that lawnmower is gone from you. It sounds like, I know you muted for a sec, but yeah, we can hear you.
They're a little bit farther away now, but I think that as far as how much time, it's like that company you're just talking about, that high growth, that doesn't know how high growth they're going to be. If they just spent a week or two thinking at what we would have called the conceptual level and just lay out the main entities, the main business areas of data that they're concerned about, then they can get into the rapid iterations that Matt is talking about. It's like, well, what's the first one we're going to dig into? Let's not, don't have to go to designing all the attributes and all the definitions, but you got to have the high level stuff, because then when you start getting into the multiple sources and the mergers and acquisitions, you have a better shot at, we can agree that this is what we meant, right? These are the things that we're talking about when we say customer, and we can see how it fits into that high level semantic model that we started with, and then use something like Coalesce to then refine it, to put it all together so that we can use it for the analytics that we need.
Right.
That makes total sense. I've seen a bunch of comments. I'm curious from the audience, for those of you who are still with us, if there's any topics that you'd like to see brought up on the next Coffee with Coalesce. I know, Matt, you've been talking with Chad Sanderson about data contracts. I think there's a lot of discussion around, obviously, data modeling, which is what we're talking about today. But if there's anything anything that everybody would be excited about, whether it be data mesh, data contracts, data products, you name it. Would love to see and hear some thoughts here as we wrap this up. That being said, any last thoughts, Kent and Matt, before we close out the session today?
Last thought, just do it. Model.
I was going to say the exact same thing.
You know, and let me just dispel one big myth for you right off the bat. For those that are afraid of jumping into Data Vault is not hard. Data Vault is just thinking about domains of data. You don't let fear paralyze you. Just jump in and do it. And guess what? You can be wrong. It actually lets you correct yourself. Just go and make it happen.
I would love to see a blog post co-authored by Matt and Kent in regards to this. I think that would be insightful for the data community personally.
Yeah, well, it is going to be what Matt said. It's like data modeling, just do it. I saw somebody recounted one of my comments. It's like the future of data modeling is doing data modeling.
Yeah,
right. It's really the future of data, right? If we're going to be successful at scale over the long haul, you have to have some form of a model. You know, we can debate for hours and hours and hours what form that model should take.
Yep.
What does it really look like, and what are the nuances of how you do that, and what tools you use, and all that.
Yep.
You got to get to that point of understanding to say, yeah, we need a model. We need to understand the data we're dealing with at a business level. Because if we don't understand that, then again, we're back to the data source. You know, you can have the greatest tool in the world, but if you don't understand the data and understand what you need to do with the data from a business perspective, the chances of delivering value from that data is greatly diminished. Right?
Yep.
Because how do you judge whether you delivered value if you didn't understand what they needed in the first place? Right?
Yeah.
You got to have both.
I agree. I mean, and it's as simple as the reason why I asked how much time it would, how big of an investment it would be for a team. You know, like you described earlier with even a early stage company. We're not talking anything crazy. If you just spent a couple weeks, weeks discussing, even for a large enterprise, I don't think it's that much.
And I'll have to say this: if you haven't done it before, get a coach or a mentor to help you.
Yeah.
Don't go try to pull a couple of books off the shelf, read a couple of blog posts by me or Matt or Dan about, the basics of Data Vault. Yes, it's pretty simple, but you want to have an expert coach, like you do with everything in life. If you've never done it before, you will get there faster if you have a guide that's done it before, right? And that's just, to me, that's common sense. That's how I learned so many things from different people over the years, from Bill Inman and from Claudia and from Dan, was by working with people who had done it before. Yeah. And so I could learn from them, and they could tell me when I'm about to do something stupid. Like, or if I did it, they could catch it sooner and say, yeah, don't do it that way. I tried it before, this doesn't work, right?
Or can't they let us do it stupid so they can tell us?
Yeah, let's fail fast, right?
Yeah.
That's right.
That makes sense. I totally agree. I think that for us at Coalesce, there's a lot of room to produce some thoughtful content around this, around how to approach data modeling, at least some educational, insightful content that we certainly look forward to. And I must say, it's been amazing having both Kent and Matt on this together. I'm so glad to bring Coffee with Coalesce back. Thank you so much, gentlemen. It's been such an amazing conversation. If anybody wants to reach out to either Matt or Kent, obviously you can just find them on LinkedIn, shoot them a message. These are two of the most helpful people I've ever encountered when it comes to data architecture, data modeling, some of these tough questions that you may have. And of course, as you know, we're Coalesce. We're the data transformation company focused on automating the vast majority of the data modeling, data transformation processes. And so if you're interested, feel free to go to our site, coalesce.io, kick off a free trial. We'll be around. We'll be doing another one of these next month. So if there are any topics that you think about over the course of the next week or two, you can contact me, follow me, message me on LinkedIn, or leave a comment here today. and we're looking forward to seeing everybody on the next one. So again, Kent, Matt, thank you so much, both of you. Amazing.
My pleasure. Thanks for having us.
Awesome.
Great being here.
Thank you, everybody. Have an amazing day.